We have getValue implemented now, but what about some of the other data methods that I remember either calling as a client or seeing in the AF data reference documentation? For example, I remember this getValues method and some of these rich data methods like interpolated values and recorded values. What's really the difference between getValues and getValue? Well, other than the obvious fact that one is going to get a value and one is going to get many values, think about the case of the PyPoint data reference. If we go to the PyPoint data reference and we ask it for a value, that's a call to the server. Well, if I want values over a time range, really what I need to do behind the scenes is make one call to the PyServer for that entire time range and get all of the values in the archive, or something along those lines. So in that case, if I were writing the PyPoint data reference, I would need to implement a different call to getValues, where I contact my foreign system, I get a bunch of values, and do something with them. However, in the case of this data reference that we are writing here, all we are doing is responding to a list of inputs from other attributes. So if I were to implement this getValues method here in our data reference, in other words, override getValues, I see that we're past various chunks of AF values, so I'd probably end up writing just a big dumb for each loop that loops through all those input values. And doing something very similar to all of the logic already up in my getValue method, right? Because we are responding to inputs from other attributes, we're not calling a foreign system, we're just responding to inputs. It really makes no sense for me to have to re-implement the same logic just inside a big for each loop. Luckily, we do not have to do that. There is a base implementation of all of these data methods, like getValues, plot values, interpolated values, all of that. For the summaries, for all of this, there is a base implementation, which does a glorified and much better version of what I was just describing, where if we're just doing one operation on the inputs, we don't need to implement all of the crazy logic for these rich data functions. The SDK already includes that, and in our case, that's exactly what we want. So I don't need to override this AF values. All I need to do is tell the SDK that it's perfectly fine to use its base implementation. So on the data reference, there are a couple properties here that are relevant. There's a supported methods property that contains all of the classic data reference methods, signaling that we do implement those. So for example, for my AF data, or for my supported methods, I would say that I implement getValue, and then even though we don't override the getValues, we're going to say we support that. That's fine, because the base implementation can be used. And the SDK will know what to do. It'll just end up calling our getValue method as many times as needed for that list of inputs that it gets for a time range. So we will implement this supported methods parameter property. So let's see, AF data reference method dot getValue. We support that, as well as, we use the logical OR here to indicate multiple values, as well as getValues. We'll talk about some of these other options later. We're going to come back to that. But for now, this is good. We support getValue and getValues. And as far as the rich data methods go, there's another enum of supported data methods. Now, on one hand, we could go through and logically OR all of the rich AF data methods, which exist as of AFSDK 2.5, or we could make use of the shiny property of, oops, it's not static, this dot default supported data methods. If we look this up in the docs, we will see that this pretty much means, hey, it's totally fine to use the base implementation of all of those rich data methods. Remember, the SDK has a base implementation that, as long as we've implemented a getValue and said that we support the base of getValues, all of these rich data methods are going to work. The SDK knows how to do all of the filtering and input getting and all of that, and knows how to do summaries. That's already included. We just have to say, yes, we are fine using that base implementation. Again, really the reason we wouldn't be fine using a base implementation is if we were making a data reference that points at an external system that's pretty much as smart as a PyServer. A PyServer knows how to do a lot of summaries itself, so in the PyPoint data reference, they don't use the base implementation here. They would let the PyServer do those summaries. But really, for the normal case here in data references where we're responding to inputs, we're just going to use this base. So we've got those supported methods taken care of. There's one other thing that we need to say what we support, and that has to do with the times that we support. So the supported contexts. Now you may have noticed this whole deal up here about receiving a context during the getValue and a context during the getInputs. That's another one of those infamous things left over from Sigmafine. The Sigmafine application is a specific user of PyAF. It's a product that OSIsoft owned at one point, and there's a lot in our SDK that still exists really only to support that. But in our case, what we want to say is that we support AF data reference context dot all. Do we really support cases? No, but the inputs should come from the right thing. We aren't having to make any external calls. Again, here, if we really wanted to be safe and pedantic, we could say that we support time and time range, but there may not be a harm in just saying all. So with that, we have not only looked at the other data reference methods that exist, but decided that the base implementation is fine, and we have told the SDK that it's okay to call that. Next, we will look at trying this data reference out and seeing how it works. If you're writing an AF data reference that makes calls to a foreign system, there's one more of these supported methods which may be of use to you. It shows up in the enumeration as multiple attributes. And pretty much it's designed to handle the case similar to when someone asks for the value of 1,000 PyTags at one time. In the example of the PyServer has an RPC that can take as an input 1,000 different PyTags and one timestamp, and it'll return 1,000 values from just that one call. We don't have to make 1,000 different calls for individual PyTag values. So if you're contacting a foreign system that can do bulk operations in that sense, this method is something you will definitely want to implement. As far as how to do that, back in the metadata, if we go to the definition of our AF data reference class, we get the metadata for this static getValue call, where for an entire list of attributes, at one time, we can get values. So to implement this, it's probably easiest just to copy that method signature right there and paste it in using the new keyword. Because it's a static method, we can't use the override keyword. We need to use new, or if you're in Visual Basic, shadows. But then we would go about implementing this just in a very bulk way. Again, this would save us potentially from having to make 1,000 different calls independently to one foreign system. But again, in this example that we're working on right here, we're not calling a foreign system, so this really isn't of the most extreme use to us.